In this video, we're going to be studying chemical quantities. We're going to be doing mass to mole and mole to mass calculations. So by the end of the video, you should be able to convert from the mole quantities of a substance to its mass, and then the reverse, from its mass to the moles of a substance. So we're going to complete a couple of questions here on some conversions. The first question says, how many moles are equal to 200 grams of calcium bromide? So the first thing we want to do is identify what is calcium bromide's formula. So calcium is a metal and bromine is a non-metal. So this is an ionic compound. So calcium forms a +2 charge, and bromine is in group 17. That's one away from the noble gases. So it will gain one electron to have the electron configuration of the noble gas next to it on the periodic table. So bromine will be a -1 ion. So if you were to make the compound calcium bromide, it would be CaBr2. You'll need 2 bromine -1s to cancel the calcium +2 ion. So this is a chemical formula, so we'll do some side work here. So the first thing, actually before we do that side work, let's set up our dimensional analysis. It says complete the following conversions using dimensional analysis. So 200 grams calcium bromide, set it up over 1. And we did a video before, on an introductory video on the mole. It's in this playlist, so if you want to look at that first. But we talked about dimensional analysis. So we want to get grams of calcium bromide on the bottom. So that way these units, grams and grams, will cancel out because they're numerator denominator. In order to do that, we have to recall that the molar mass is equal to the grams in 1 mole of a substance. So we need to use the molar mass to convert from grams to moles. So we need to find the molar mass using the periodic table. Now, what I did was I just pulled the little screenshots of the elements as they are on the periodic table. So calcium you'll find in group 2. And if you look at calcium, it has a molar mass of 40.078. And bromine has a molar mass of 79.904. So we have calcium at 40.078. And then we have bromine. Now there's 2 bromine atoms. It's Br2 times 79.904. We'll walk that back. 79.904. Then we'll add these up. We'll get 199.89 grams per mole. So we'll do 199.89 grams per 1 mole of calcium bromide. And it says how many moles are equal to 200 grams. So we were in grams. We got our grams canceled using the molar mass on the bottom. We have 1 mole on top, and now we're left with moles. And so we need to multiply 200 times 1, which is 200, divided by 199.89. And that gives us 1.00 moles. 1.00 moles of calcium bromide. 1.00055. So 1.00 moles. It makes sense because a mole is about 200 grams and we have 200 grams. So works out. All right, see the next one. All right, the next one is how many grams are equal to 3.46 moles of chlorine? So one thing we have to remember here, chlorine exists as Cl2. It's diatomic. So when we do this, the molar mass of chlorine is 35.45. So it'll be 35.45 for one chlorine, a mole of one chlorine atom, but it's times 2 because there's 2 chlorines. So if we multiply by 2, so we get 70.9 grams per mole. So we have 3.46 moles to start. That's what they give us in the problem. And it's Cl2 over 1, so I don't put anything on the bottom. And then for every 1 mole in the denominator, why do I got to put 1 mole down there? Because I got to cancel out moles that are on the numerator. So these got to be opposite of each other to cancel out. And then for every 1 mole of chlorine, there's 70.9 grams of Cl2. Then we'll multiply 3.46 times 70.9. That'll give us 245 grams of chlorine. Okay, that's our second one. I mean, 1 mole is only 70.9 grams, so it makes sense that 3 over 3 moles would be 3 times, over 3 times that number. All right, let's do the next one. How many moles are equal to 145 grams of potassium carbonate? All right, so with this one here, it's how many moles are equal to 145 grams of potassium carbonate. So this is a metal, and carbonate is a polyatomic ion. That's a nonmetal. So this is an ionic compound. So potassium will form a +1 ion because it's in group 1 of the periodic table. And the carbonate ion is CO3 -2. This whole thing is a -2 charge. So you're going to need 2 potassium +1s to cancel the carbonate -2. So the chemical formula for potassium carbonate will be K2CO3. And we'll need this to get the molar mass of potassium carbonate. So we'll start with our 145 grams of K2CO3 over 1. And then we need the molar mass of potassium carbonate on the bottom so that the units cancel. And we have 1 mole of K2CO3 on the top. And that'll get us to moles. And then our grams are on the denominator and the numerator. And remember in math, if you have the same units in one in the numerator and one in the denominator, they'll cancel out. So if we go to our periodic table here, I pulled the screenshots. Potassium is, there's 2 potassium atoms, K2, right? K2. So it's 2 times 39.098. And then carbon, 1 carbon atom, it's 12.011. And then oxygen, there's 3 oxygens in the formula, CO3 times 15.999. And then we'll add these up. So the molar mass here will be 138.204 grams per 1 mole. So we'll do 138.204 grams per 1 mole, and then we'll multiply 145 times 1 to get 145, and then 1 times 138 to get 138.204, and then we'll divide those two. And the answer we'll get is 1.05 moles of K2 CO3, or potassium carbonate. All right, so the next one. How many moles are equal to 13.25 grams of magnesium sulfate? All right, so start with the 13.25 grams. Now, magnesium sulfate, again, this is a metal, and sulfate's a non-metal. So magnesium is a +2 ion, and sulfate is SO4 -2. So it's a good idea to kind of memorize your polyatomic ions and know your charges from the periodic table. Magnesium is in group 2 of the periodic table, so it loses 2 electrons to go backwards to the nearest noble gas. And so when it loses 2 electrons, it becomes a +2 ion. So you'll notice that Mg +2 and sulfate -2, those charges already cancel out. So the formula for magnesium sulfate is Mg SO4, since the charges already cancel. In order for an ionic bond to form, the charges have to be able to cancel out. So we'll do grams of magnesium sulfate on the bottom. Since they want to know moles, we're going to add our moles on the top. That'll be per 1 mole. So we'll go over here. Magnesium is, there's 1 magnesium, so it'll be 24.305. And then sulfur will be 32.06. And then for the oxygen, we already had oxygen in the previous problem. So it's right here. It's 15.999. So that'll be, there's SO4. There's 4 sulfurs. There's 4 oxygens. And so it'll be 15.999 times 4. And then we'll add all those up. So that'll give us 120.361 grams per 1 mole. So we'll do 120.361, and then we'll divide 13.25 divided by 120.361, since there's just ones on the everywhere else. And then that'll give us 0.11 moles of MgSO4. And so we don't even have close to half a mole. The molar mass is 120. We only have 13 grams, so we don't even have close to a full mole of magnesium sulfate. All right, and then this last one. How many grams are equal to 0.11 moles of iron 3 chloride? So if we remember back to our naming unit, and we'll put a video in the playlist that we haven't already under chemical bonding on how to name these compounds so you can remember. That's why it's really important to know previous concepts in chemistry, because they all build. So with this one here, iron 3. What that means is that the iron, this chemical symbol for iron is Fe. That means it's a +3 charge. That's what that Roman numeral 3 means. Iron can be a +2 charge as well, and so it's really important to know in the nomenclature and the naming what ion it is, so you can get the quantity correct. And then chlorine is in group 17 of the periodic table, or group 7A, so it's one away from noble. And as we saw before, it's always a -1 ion. And so however you want to, think about this, but if you cross your charges, give the 1 to iron, give the 3 to chlorine. The formula is FeCl3, iron 3 chloride. So when we write this, we have 0.11 moles of FeCl3. Put that over 1. And then we got to get our molar mass. So 1 mole of iron 3 chloride is equal to the grams of iron, the molar mass of iron chloride. So for iron, it's there's 1 iron at 55.845, and then there's the chlorine's molar mass is 35.45, but there's three chlorines, so 3 times 35.45, and then you'll add these up. So that's why it's really important to get this formula right. If you get that formula wrong from your naming compounds, then you'll get the wrong molar mass, and then you'll get the wrong chemical quantity. So it's really important. So the molar mass is 162.204 grams per 1 mole. So 162.204. Now we'll just multiply 0.11 times 162.204. And we'll get 17.8. We'll just do, what we'll do is we'll round this up. We can talk about sig figs later. If you don't know what sig figs are, it's basically what your answer should be. Technically, this is 2 sig figs, so it should be rounded up to 18 grams. We'll just do that, 18 grams of iron chloride for right now. We'll talk about more about sig figs in a later video. 18 grams, or 17.84 grams to be exact. All right, well, I hope this helped. This is how you convert from grams to moles or moles to grams. And this allows us to quantify how much of a substance that we have. In a later video, we'll be putting this all together in our stoichiometry unit, which is after our chemical reactions unit, and after this unit. And it allows us to do a chemical reaction and then predict how much we might produce. And we might produce iron chloride here as a product, and we'll have some more chemicals involved. But these are basic one-step conversions. You might put the previous video together, so the one before it was on the mole, and now we're using the mole to get to grams, and vice versa. So if you want me to do any other problems or you have any questions, put it in the comments below, and I'll try to do a video on that particular question that you have.